So the next speaker is Commander Gabrielle McGrath. She's going to be talking about the International Ice Patrol.
This button is laser pointer, and if you hit either of those, it'll back out. Don't worry, just hit it again.
Okay, great, thank you. Good afternoon, everyone. As Pablo mentioned, I am Commander Gabrielle McGrath, and I'm the commander of the U.S. Coast Guard International Ice Patrol. For my talk today, I am going to start off just with explaining the Ice Patrol mission, just for those that are unfamiliar with it. Then I'm going to go into our 2017 ice season and give you a case study that we had this year with this situation that we had that happened at the end of March, beginning of April, that the media called an Iceberg Explosion. So hopefully that'll be of interest to everyone. I'm going to cover our status of using satellite reconnaissance to detect icebergs. And then I'll finish up with some support that we're going to be doing for the U.S. Coast Guard cutter Maple this summer. So just to begin. So to take a look at the Ice Patrol mission, the latitude of 48 degrees north is considered a very important latitude for us. It is what we consider to be the nominal northern boundary of the transatlantic shipping lanes. So when we're looking at how severe an ice season is, we consider the icebergs that have drifted or are detected south of that line of latitude to gauge how severe an ice season is. This box denotes where we actually conduct our aerial iceberg reconnaissance. So we go up to 60 north and then east and west and south, really to the extent of where the icebergs exist in any given season. These red lines are a little bit hard to see here, but they designate the transatlantic shipping lanes. And as you can see, the Great Circle route coming across the Atlantic Ocean cuts just south of the island of Newfoundland. The problem with that is that the icebergs calve off of the glaciers of Greenland and travel south in the cold Labrador Current right into this area of risk of the transatlantic shipping lanes. The difference with our mission compared to a lot of the Arctic missions is the mariners that are looking at our ice products are people that are not familiar with seeing ice and don't want to see ice. They want to get across the Atlantic safely and efficiently as possible without interacting with it. And that star there at the bottom just designates where the Titanic sank. A lot of people often think that that was much further to the north, but it was actually there at the tail of the Grand Banks. This graph designates the interannual variability of the number of icebergs south of 48 north in any given ice season, dating from 1900 to present. As you can see, the bars to the right of the graph you see a lot higher bars to the right, and that designates the modern reconnaissance era when aerial aircraft were used to look for the icebergs. Over the last couple of ice seasons, we've had 4 extreme ice seasons in a row. And we are currently at 993 icebergs in the shipping lanes for 2017. So ice still poses a threat to mariners. I think you've heard a lot about that this morning. Definitely covered in Dave's talk just a few minutes ago. The picture just to point out to the right is the Federal Kushiro. This vessel back in 2009 actually went through our iceberg limit, did not heed the warnings of the Ice Patrol, and struck ice heading through the Strait of Belle Isle and was put into dry dock for some time. We're very proud of the fact that for vessels that do heed our warnings, no vessel has struck ice in the 104 years since the Titanic. But for those that do not heed it, they can have issues. So how do we produce our warnings for the ships? We take all the reconnaissance that we get from our missions, from commercial area reconnaissance, from ship reports. We feed that into a computer model in our operations center that's located in New London, Connecticut, that uses the environmentals to predict the positions of the icebergs. And then we create the product there on the right. And just to show that a little bit in more detail, this is called the North American Ice Service Iceberg Chart. We work in concert with the Canadian Ice Service. It was a very long partnership that we worked with them from approximately about 2006 till 2011. We used to each produce our own chart. Now we just produce this one chart. The Ice Patrol creates this between January and the end of August, and then the Canadian Ice Service creates the exact same product in the fall months. The way that is designated is when the icebergs are threatening the transatlantic shipping lanes, the Ice Patrol creates the chart, and then when the icebergs are threatening the Canadian coastal waters is when the Canadian Ice Service creates the product. Just some things to note on this. The solid pink line that you see here is what we call the iceberg limit. So what we're saying to the vessels is if they stay outside of that pink line, they'll be safe from the danger of iceberg collision. You'll note that this part of the line up here is dotted. That is what we call the estimated iceberg limit, and that was created in partnership with the Danish Meteorological Institute, who provided data to us monthly, climatological data as to where the iceberg extent is. An initiative that we have moving forward with the Danish Meteorological Institute is actually to add iceberg observations in this region south of Greenland. The numbers that you see here are the number of icebergs per 1 degree of longitude by 1 degree of latitude. And the dashed line that you see is the actual sea ice limit. We get that from the Canadian Ice Service. And another recent addition to our chart is to actually have the sea ice limit off of Greenland as well, that is also provided by the Danish Meteorological Institute. One more thing to note is that we also put on the chart the date of the most recent reconnaissance and the era. The date of that and the area that they covered, that is something that came to us as a feedback from the Queen Mary II, that they wanted to be aware of where we had most recently done reconnaissance, and that's something we added to the chart 2 years ago. This is a new product that we just created this season. It's called the 7-Day Iceberg Outlook. My chief scientist, Mr. Michael Hicks, produces this each week, and it provides a week outlook to what the iceberg conditions are going to be off of Newfoundland and off the Labrador coast by the week. So how do we get these products out to vessels? It is sent out by pretty much every means possible. We use the internet, we use radio broadcast, and we use Inmarsat to get the product out to vessels in any way possible. So how do we get the iceberg data that we collect? Obviously, as I mentioned, we do get reports from ships, from commercial area reconnaissance flown by the Canadian government, also for the oil and gas industry. But the way that we achieve our own observations is mostly by aerial observations. We use the HC-130J aircraft that is based out of Coast Guard Air Station Elizabeth City in North Carolina. We do missions of approximately 9 days, twice per month, to base out of St. John's, Newfoundland, and fly out to the extents of the iceberg limit looking for icebergs. We do this using typical search patterns with 25 nautical mile track spacing. Something that we are bringing into replace some of those aircraft hours now is the use of satellite technology. A couple of years ago, we came up with this satellite concept of operations, where we have designated different areas within our operating area where we can use satellite technology. There are still some challenges with this technology. Our validation efforts that we have conducted thus far between what the aircraft can find and what the satellite detects is only about 50%. So we are not confident to use that data in the most dangerous areas of the shipping lanes right here. So in areas B and C, we do not add our direct observations from the satellites into our database. Again, just because a lot of more risk there, smaller icebergs, a lot greater chance that the targets detected by the satellites could be something else. But in the area A, we are using those observations directly. And something that we achieved this season was we actually procured a license for Iceberg Detection Software, that we actually share that license with the Canadian Ice Service. So we can download imagery in our operations center and analyze it in-house. And that was the first time that that has ever happened. And so it was a great accomplishment this year in 2017. And you can see the numbers up here for Area A, how many images we achieved this season and how many icebergs we added to the database. And then in Area B and C, we are still looking at those images, so you can see how many we had in that area, but we did not add any icebergs just based on our current policy. So back in January was the first time that we actually did all of that whole process in-house, where we achieved the image, downloaded it, analyzed it, and then added the targets to the database. So that was a great milestone in our history of using satellite technology. So just to show how this technology is very difficult, as you've seen from the last two presentations from Commander Lane and Mr. Jackson, the use of satellite for sea ice, for the synthetic aperture radar, it's pretty clear to see, and again, not minimizing how detecting by sea ice, but you could kind of see the edge of the sea ice there, if you look at it. And if you want to overlay the Canadian Ice Service product, you could see where that ice edge is on that imagery. Doing the same for icebergs is not quite as simple. This is just a picture of a flight that we did for a iceberg validation with a satellite image. So you can see how the image right here is overlaid on top of our flight track. And these are some actual pictures of iceberg targets that were collected during that flight validation. And this is over sea ice, which is very difficult to detect icebergs within sea ice using satellite imagery. So this is really hard to see, even harder than normal to see on this screen. But you could see this white triangle, if anyone could see that. That was an iceberg detected during the flight. And there's obviously a time difference between when the satellite image was collected and when the flight was conducted. So typically we try to make that under 3 hours or so. So the icebergs move, but they don't move that much. And these little blue circles denote the icebergs that were found from running the iceberg detection software on that image. Now, again, this image is not very clear on the screen, but I would challenge you to find, be able to find an iceberg within that. It's very difficult to see. So this is a validation test that we did with Sentinel-1A imagery back in March of this year. So just to orient you, this is the island of Newfoundland, this is Quebec up here, Strait of Belle Isle right here, so going into the Gulf of St. Lawrence. So this is the actual image. These are the targets that were found using the Iceberg Detection Software. These were all of the targets detected. And our policy right now within our operations center is only to use the high confidence targets that come out of that evaluation. We are just learning to do the satellite analysis. Our people are currently trained to be aerial ice observers, so they're learning this new technology. So just as part of our policy to kind of take back from the number of targets that are detected, we are using the high confidence ones. So again, I apologize, that's a bit hard to see, but so those are red, kind of just in this area here, were the high confidence targets. And then we conducted a flight in this area. That was our flight track, and you could see the blue targets. So obviously, the correlation between those is less than 50% on this image, what was found from the flight and what was found by the satellite analysis. This is a validation test that was actually done by the oil and gas industry on the Grand Banks. So you see the flight that was conducted. This was done by the Provincial Aerospace Limited. The green line there is their flight track, with the green triangles being the iceberg observations from that flight. And this is the satellite swath with the icebergs detected from the satellite analysis. And as you can see, there's actually 0% correlation between the two, and this is in open water. So these are just some of the challenges that we're looking at and why we have not completely incorporated this technology, but we're very proud of the fact that we are now using it and taking advantage of that extra source of reconnaissance. So just to capture some facts from the 2017 ice season, as I mentioned, we're currently at 993 icebergs in the shipping lanes thus far. We do keep counting that data the whole way till September 30th. It's basically on the fiscal year, so that number could rise by the end of the year. But this is our 4th extreme season in a row. So you can see the numbers there from the last 4 seasons, very high numbers. One thing to note is just back in 2013, we only had 13 icebergs in the shipping lane. So we often get asked of the question of global warming and our calving rates increasing, and is that why we're seeing more icebergs in the shipping lanes? But what we have found is that there's a very strong correlation between the North Atlantic Oscillation Index, which shows basically how the wind and atmospheric conditions are set up in the season, and that really affects how many icebergs we have in the shipping lanes. So this year was so far the 19th most severe season on record, dating back to 1900. This year, a lot of our icebergs were shifted to the west. Last year, we had a very eastward distribution of icebergs, so it's interesting how every year varies based on the pattern. We expended 295 flight hours, which was a strong reduction from previous years. The last 2 years, we used over 460 flight hours, so using the satellite technology has allowed us to reduce those flight hours a little bit. And we also had some issues with weather that also impacted that as well. And as I mentioned, the first time incorporating the satellite data. So now I'm going to get into this season explosion that we had in late March, early April. So back on March 27th, this low pressure system came across the Atlantic and set up here and spun pretty much in place for about 3 days with hurricane force sustained winds. This was a very interesting atmospheric condition, and those counterclockwise winds pulled right into the area where the Labrador Current pulls the iceberg south. If you can see that this blue line here, that is the 1,000 meter contour, and it is the driving area of the Labrador Current. So you're already having the current bringing the iceberg south, and then that combined with these counterclockwise winds from the north really pulled the icebergs down into the shipping lanes. This is just another pattern. This is a surface level pressure chart. You could see the strong, for those of you weather geeks out there, you could see the strong, tight isobars here, which created those strong winds. And again, this is going to be a bit difficult to see, but I was actually on this deployment. We conducted these 2 flights on March 24th and March 25th. And you could see, again, this is the 1,000 meter contour, a little bit hard to see. But the southernmost and easternmost iceberg that we saw between both of those flights was right here. That system came into place between the 27th and 28th. We did another flight in the same area on the 29th, and you could see all of the icebergs that came into the shipping lanes in such a quite short period. I was actually on this flight, and the icebergs that we actually plotted here are probably only half of what was there. There were so many in the area that we couldn't even actually count them all. It was absolutely amazing. And in a 1-week period, from the 27th of March through the 3rd of April, we jumped from 37 icebergs in the shipping lanes to 455. Incredible. So this is just going to show you what our product looked like over that course of that period. So this one is from the 27th of March, 1st of April, 3rd of April, and then the 11th of April. During that period alone, between just the 27th of March and the 5th of April, we had 7 icebergs that were detected outside of our iceberg limit. Now that is something that typically in a given season we'll have 1 or 2 typically. It's something again that we pride ourselves on, making sure that our warnings are accurate and that we're letting the maritime community know where those dangerous areas are. And just in that period, we had 7 icebergs outside the limit because of how quickly, our model couldn't even keep up with how quickly they were moving to the south. The oil and gas industry on the Grand Banks was inundated with those icebergs. For any of you that are familiar with that, there's an extreme oil rig population there on the Grand Banks. And there were so many icebergs coming onto the rigs, they'll do towing operations a lot of times where they'll actually lasso the iceberg and tow it away from the rig. But there were so many that they couldn't even get that into place, and they were using water cannons to just basically stand on the rigs and on boats around the rigs and spray the icebergs away because there were so many coming onto the rigs so quickly. This was huge in the media. We did an article, I did an interview with the Associated Press that pretty much went viral. It actually was in over 350 print articles worldwide. We had some live interviews on the NPR and the Weather Channel. We were on CBS International News. So it just was a crazy time period for us. And then I'm just going to get into some of our partnerships here real quickly. You've heard a little bit about the North American Ice Service, both in my talk and the 2 previous talks before mine. I mentioned the work that we do with Canadian Ice Service for creating our product. We also work with them to gain commercial aerial reconnaissance each week. We request tasking in certain areas, and then CIS hires the commercial provider to do those flights. I worked very closely with the NIC to access RadarSat-2 imagery through the National Geospatial Intelligence Agency. Sorry, I'm trying to go quick, Pablo. I see you standing there. And we also gained access.
On me is the Admiral. He's ready to go.
The Satellite International Data Hub, that gives us more quick access to satellite imagery within our operations center. And then we act as a COOP alternate site, so a continuity of operations site with Canada. And that was something that we tested 7 times during the season successfully. Both of the previous talks spoke about the International Ice Charting Working Group. That's something that we are, work closely with as well. We're a charter member. I am the chair of the Iceberg subcommittee on that group, and we are working to standardize iceberg warnings worldwide, as Dave had mentioned in the previous talk. And then just to mention, I think this is important to mention with this group, a lot of our talk today has been on the United States responsibilities in the Western Arctic around Alaska. But just to remind everyone, we also have responsibility in the Eastern Arctic as well. The U.S. has responsibility for NAV Area 4, as you can see over here, which runs from 7 degrees north the whole way up to 67 degrees north. So we are responsible for those navigation warnings on the eastern side of the Arctic. And for any vessels that are coming in and out of the Northwest Passage, we would need to provide those warnings to those vessels as that becomes more of a viable shipping route. Something we will be doing this summer in working with the National Ice and the Canadian Ice Service is providing support to the Coast Guard cutter Maple. That is a seagoing buoy tender based out of Sitka, Alaska. She will be transiting on the yellow route that you can see here through the Northwest Passage down to the Coast Guard Yard in Baltimore. We will be providing iceberg information for the vessel, basically when she comes out of Lancaster Sound until she arrives in port in St. John's for about a 2-week period. And this is what that product is going to look like. This is just an example that we provided to the vessel before she got underway, showing the sea ice edge, which the National Ice Center and Canadian Ice Service will be providing more details on that. But we are going to be providing areas of where the iceberg concentration is. And these words that you can see here, isolated, few, and many, are definitions that we've been working with the International Ice Charting Working Group Iceberg Subcommittee to come up with those definitions and to recommend to the vessel, for instance, in an area of isolated vessels, they could pretty much proceed as normal, compared to when there's an area of many icebergs where they're going to want to post extra lookouts, slow their speed, and just be aware of that. And this seems probably pretty rudimentary, setting up these areas, but this was actually done using extra wide swath imagery from the Sentinel-1A satellite, and then setting up these areas based on the concentration of icebergs in a given area. And that's it.
Thank you, Gabrielle. Thanks for a very interesting presentation and very informative. I would suggest if anybody has questions, they could find you during one of the breaks.
Thank you.
Yeah.